All right. Guys, when a equation or a situation gives you a point and a slope for a linear equation, you have to use point slope form, okay? You can't go to slope intercept because right now with this information given, I don't know the y-intercept. I know the slope, but I don't know the y-intercept. So I'm going to use this formula up here, y minus y1 equals m times x minus x1, okay? And so to kind of label what all these things are, we know that our slope is our m. That's always been that way. So I can go ahead and plug in a -4 where that m goes. And then these two coordinates, that's just x1 and y1. It's the x and y coordinates from my 2 points. So I would say, okay, y minus, well, y1 is -6, x minus 3. Okay, so now if I just write this a little bit cleaner, y minus -6, when you've got that double negative happening right there, you can go ahead and write that as y plus 6 equals -4 parentheses x minus 3. And I had some people in class not putting the parentheses in there. That is a big issue, okay? Because in algebra, when you see parentheses, that typically is going to mean that you're distributing somehow. Now, we like this. This is okay. That's point slope form. The problem is we always want, and we're always trying to get back to y equals mx plus b. So we're going to try and rearrange this to turn it into that version that we like so much, y equals mx plus b. So I kind of gave you a hint already on this. We're going to distribute -4. So I end up with -4x, and then -4 distributed to a -3. Still got lots of people messing this up, guys. That makes a positive 12 in this situation. Okay, I'm not going to be forgiving on that. You've got to get that tracked down. A -4 times a -3 is a positive 12. And then I'm left with y plus 6 over here. I'm getting closer to this mx plus b, but I still don't have y completely isolated. So I'm going to go ahead and subtract 6 to isolate that y. And I end up with y equals -4x plus 6, positive 12 minus 6. This version is awesome because I see, hey, there's my slope right there, -4. It makes sense that the slope I get down at the bottom matches the slope they told me in the beginning. That's the slope. This is also the slope. And then my b value, that would mean my y-intercept for this graph, it would begin at positive 6. So if you began at positive 6 and you moved according to your slope, down 4 over 1, down 4 over 1, down 4 over 1, you would end up at 3 and -6, okay? All right, for my second example, same concept. I have a point and a slope, so I know I'm going to start with point slope form. If I label everything here, I've got there's x1, y1, and m. So just to kind of keep it nice and color-coded for you, y minus 5 equals 3/2 x minus -8. It's really important that you put the signs in there so you have a minus and a negative happening here. So just to clean it up, y minus 5 equals, oh, I guess I could skip a line to give myself a little bit of space. Y minus 5 equals 3 over 2 x plus 8. Okay, subtracting a negative is the same as adding. Now, same concept. I want to move it to y equals mx plus b, so I'm going to distribute first. First part's easy, 3/2 x. For the back part, you can take this to a decimal if you want for the multiplication, but I want you guys to start getting a little more comfortable with, okay, I'm going to multiply 3 times 8, but then the division bar on this actually means to divide by 2. So I'm going to do 3 times 8 is 24, but then I have to divide by 2, so that actually makes a positive 12. Okay, positive times a positive is a positive. So y minus 5 equals 3/2 x plus 12. Now to isolate y, I'm going to add 5 to move it to the other side. That way it cancels out on that side. So y equals 3/2 x 12 plus 5 is 17, positive 17. Okay, so if they give you a point and a slope, it's easy. You just plug straight in. If they give you 2 points, it's a little bit trickier, okay? Because you don't have the slope. And for slope-intercept, you need the slope. For point slope, we need the slope. So no matter what linear equation you're going to do, you're always going to have to find the slope first if they don't give it to you. So to find the slope, I'm going to say, okay, m equals y2 minus y1 over x2 minus x1. That's just the slope formula that's on your formula chart, which you all now have a copy of. So I'm going to plug in, let's see, okay, so that would be x1, y1, x2, y2. So I'm going to go 2 minus 1 over 2 minus 4. All right. 2 minus 1, I'll write this out clean, 2 minus 1 and 2 minus 4. 2 minus 1 is 1. 2 minus 4 is negative 2. So that gives me a slope of negative 1/2. It doesn't matter if you move that negative out to the side or up in the top. That is my slope. Okay. Well, now let's think about what information I have. I have a slope and I have some points. Slope and point means I'm going back up to point slope form. So I'm going to do y minus y1 equals m times x minus x1. All right, and plugging in, it's going to be, well, I don't think we need to color code it. Y minus y1 is 1 equals my slope I now know is negative 1/2 times x minus 4. I used x1 and y1 from up here. I could have used x2 and y2. Actually, it should work out the same. Just be careful that you're not using from 2 different points. You've got to use from the same point when you plug in down here. So the 4 and the 1, I've got to use those. Okay, when I distribute, I get, let's see, y minus 1 equals negative 1/2 times x is negative 1/2 x. Negative 1/2 times negative 4 means I've got a positive, let's see, 1 times 4 is 4, but then I have to divide by 2, so that makes it 2. Again, flashback from the past, you can also just think of that as what's half of 4. It's a little easier on this one. Okay, now let's see, I still got to isolate y, so I'm going to have to add 1 so that negative 1 plus 1 cancels out. We're also going to add 1 over here. So y equals negative 1/2 x plus 3. Okay? So if you don't have the slope, you've got to find the slope first. Here's another example. Try and work this one out. And I'll put it in the text somewhere. But look at this one and see if you can kind of figure this one out. I can tell you, well, no, I'm not going to take that time. All right. If they give you kind of an odd slope, I have a point of 4, negative 6, and I have an undefined slope. Well, undefined slope or no slope, it's not just that they're not telling you what it is, they're telling you it's undefined or there is no slope at all. So let's see, I remember that when it's an undefined slope, that means I'm talking about a Vux situation, okay, because that's that undefined right there. And I know that Vux tells me that we're talking about a vertical line and that the equation of a vertical line is x equals something, okay? So I know my answer is going to be x equals a number. Now, when you start looking at this ordered pair information that they have, well, I need x to equal a specific number. So if you think about it kind of logically, if this is your x value and this is your y value, oh, it's telling me that the x actually equals a 4, okay? To sketch a little picture of what that would look like, they're saying, all right, if I go to the point, oh, I did not draw my graph right, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. I have a dot down there and an undefined slope. I still have to know that that is a vertical line. And I have to know that it's x equals. then you can actually look at the graph and go, oh, okay, so it's crossing right there where the x is a 4. Okay, so that kind of makes sense. Same thing if I reverse it and say, well, now I want you to have a 0 slope. I know that Hoy tells me that this thing has, oh, is that going to drive some of y'all nuts that I didn't mark it the same way? It's telling me I have a 0 slope, means this is a horizontal line, and the y tells me that it's going to be y equals some number. Okay, so again, same logic as before. Y equals a number. Well, if that's x and that's y, then the y has to equal -6. Okay, hope this helps if you're struggling with point slope, and especially when they don't even give you the slope at all and you're having to find the slope first. Okay, so good luck.